Hi guys, this is a video demonstration of the Test Electronics Prober pre-final functional test fixture. Now what I mean by pre-final functional test is all these circuit boards are going to be tested together, but they have all been tested before. Now the reason we're testing them again is because we're going to put them together and there's been some minor changes. For example, this circuit board, this cable has been added. Now this cable has a whole bunch of different colors on the wire that all have to be soldered to the correct pad on this board, and it's important that the correct color is on the correct pad. So that's what this is going to be tested for, and also they added a beeper to this. And then this board, really the only thing that's been done with this is some connectors on the back, which is easily accommodated by lowering some test pins here, but the main thing this board needs to have happen to it is to be programmed for the specific application that this whole keypad unit is going to be going out for. This is an RFID keypad unit, by the way, just so you know what it is. Sometimes people like to know that. Now this is the keypad, capacitive touch keypad. Now we could test this keypad simply like this, flat on the test fixture, but that's probably going to pass very easily. What we want to do is test it in the configuration that it's in, which is bent like this, where these crimp connections are stressed and could be pulled loose from the traces in the flex cable. It doesn't happen often, but it does happen, and it's nice to catch it before everything's assembled and sealed. So basically this flex board is assembled into the housing and tested like in this condition. So let's install this in the fixture and I'll show you how everything works. So first we'll install this board, and basically you just put the cable through, put the board on the fixture, and the cable goes through and locks in place here. Here we have test clips, and each of these test clips you connect up the wire, the correct color wire. You just match the color of the wire with the color of the clip, and we got a whole bunch of them here. I'm no expert at this, but even I can get this done fairly fast. These just connect up to each one of their respective clips in the respective color, just like that. And then this board just drops in here like it would on any normal circuit board test fixture, and this keyboard unit just sits right on here, like that. And then you close the fixture, lock it down, and you run your tests. Now I don't have the programming equipment to demonstrate a test, but I can basically give you an idea of what it does. You would power it up, you'd check that the power LEDs were working okay. This would cycle through all on, all off. You'd make sure all the LEDs are working. And then what you do is you just push your finger across here and make sure the corresponding LED lit. Now the way this works is we got a bunch of switches up here that you can set to different modes for testing different parameters. And in here we have some data acquisition cards. One data acquisition unit here connected to the RS-232, and right here is an AVR programmer connected to the AVR port right here onto those test pins. This is just a basic AVR board from these guys at Atmel, and put in our little plastic mounting here so that it's a rear panel mount instead of just a bubble. What I really want to show you here is the way these pins are installed. Notice that they're not wire wrapped and they're not soldered. They're not solder cup. They're basically they are wire wrap receptacles, but they're inserted. Our automated equipment has vision, so it just takes us one extra step to program it to insert these receptacles so that they're all square with each other, so that this can be done, so that a basic header, female header, can be placed over this just like it was a 0.1 inch by 0.1 inch male header. And then these are just inserted, inline headers inserted just like they would over a male header, because all these receptacles are square with each other. And it makes it very convenient. The signal processing board can be connected right direct to the keyboard driver with a jumper, and the keyboard driver can be connected direct to the keyboard with that jumper. And then we got the RFID pickup coil and those clips in the back. And that's basically all there is to this fixture. Now back here at the back panel, we've got a programmer for the main data board, which doesn't really get used very much. If this board was tested and programmed, and then maybe a month ago, and then maybe some changes were made a week ago, they have the option of being able to reprogram it before they put it together in its final assembly. This is always programmed for whatever application specific this unit's going out for. And the RS-232 for data acquisition. Here we have power input from a benchtop variable power supply, powering everything, the data acquisition board, the programmer, and then here we have a current loop which monitors the current from the power, just the current being used by these boards here. So that's all there is to the back panel. This is a basic way to test all these boards prior to final assembly. So then to remove these boards, they would just be pulled out simply like this, and then they could be assembled. This board goes here like that, and then this goes like this, and then they can all be soldered in place, packaged together, and sealed. And what this does is it's a pre-final functional assembly test that ensures you that this extra stuff that's been added after the boards have been tested is all going to work before you seal it, thus saving waste and saving money. So that's the way that's done. This is the Prober, Test Electronics Prober circuit board tester configured as a pre-final functional test fixture. And if you found this video interesting and you'd like to see more videos like this, there are more available at testelectronics.com. Thank you for watching.